Alright, so we're going to graph a square root function, and so let's define what a square root function is before we actually get into any graphing. So a square root function is a function that has a square root symbol, and underneath that square root symbol there is a variable, that what we call the independent variable, which usually we use x for independent variable, that needs to be under the radical sign. So if you take a look at these three problems down here, in each of them there is a square root symbol, but not all of these are square root functions. This one I would say, yes, is a square root function because that x is underneath the radical. That's good. So that's a square root function. Okay, the second one is not a square root function. There is a square root in the problem, but x is on the outside. This is actually a linear function. If you graph this, you're going to get a line. So this one's not a square root function. And the third one, I would say, yes, this is a square root function. The square root of x plus 2, x is underneath the radical. That's good. Square root function. Okay, so we're going to be graphing ones that look like number 1 and number 3. And we're going to see that we don't get the same shape. If I were to graph number 2, I'd get a line. We're not going to get a line when we graph number 1 and number 3. Okay, so let's go through the process. So when we're trying to graph radical functions, this is the first time we actually have to be really careful about the numbers that we pick when we're plugging in values. So we're going to use an xy table. Up to the right here, I have an xy table. And we're going to pick values to plug into our function. But here's the catch. We can't plug in whatever we want into a radical function. There's numbers that won't work. And in this case, the numbers that don't work are any x values that are going to make a negative number show up under the square root. If I said, what's the square root of -2, you can't do that. Okay? So we have to make sure that when we're creating our list, we're creating it only with values that will make the number positive. Okay? So let's take a look at how we figure out where to start. So in this example down here, I want to plug in some values, and so I'm really trying to figure out, well, what is the domain? Right? The domain is the list of numbers that we're allowed to plug in. So I'm going to say, well, x minus 3 is allowed to be 0, and it has to, or it has to be positive. So I'm going to actually say that it can be greater than or equal to 0. Okay, so I'm going to say if I add 3 on both sides, that x has to be greater than or equal to 3. And that kind of makes sense. If I plug in a 3 here, I get the square root of 0, which is 0. I can do that. And if I plug in 4, I get the square root of 1, and those are good numbers. But if I plugged in, for example, 1 here, which is doesn't fit this answer that we have. If I did the square root of 1 minus 3, I'd end up with the square root of -2, and that's not something we can do. We're not going to get a y value for that, so I can't do that problem. So I'm not going to be able to plug in those kind of values. So when I start my table, if I were graphing y is equal to the square root of x minus 3, I would start my list at 3 and move on from there. Okay? In the second example, I have a little bit more going on. Right? So when I'm simplifying this one, I'm going to actually say just what's underneath the radical. 4x plus 16 has to be greater than or equal to 0. That 2 that's on the outside, that's going to affect our graph and our xy table, but it doesn't affect the domain at all. The domain is only coming from the 4x plus 16. So in this case, I get that 4x is greater than or equal to -16. Divide both sides by 4, and I get that x has to be greater than or equal to -4. Which means this one I can plug in some negative numbers. I could plug in -3 or -2, and I'm okay. Those are part of the domain, right? But if I plugged in -5 or -6, those are bad. So when I'm starting my xy table for this function, I would start it at -4. Okay. Here's our last one. Okay. Y is greater than or y is equal to the negative square root of x. Right. So for this one, I'd say, well, underneath the radical is just x, so x has to be greater than or equal to 0. That's finished. I don't have to solve that one anymore. Right, so that I can start my list for this particular one at 0. Okay, so let's use that idea and actually graph a function. So here's my function: 2 times the square root of x minus 3. So the first thing I have to do is actually find the domain, which we actually just did for this particular problem. I'm going to come off to the side and I'm going to say x minus 3, which is underneath the radical, it has to be greater than or equal to 0. So that means that x has to be greater than or equal to 3. Okay, so when I'm making my xy table, I'm going to start my list at 3. I'm going to say 3, 4, 5, 6, 7. Right? That would give me a good arrangement of numbers, a good list of numbers, and I'll see a shape. Okay? So when I plug in 3, it's going to look like 2 times the square root of 3 minus 3. Okay, well, 3 minus 3 is 0, and the square root of 0 is still 0. 0 times 2 is still 0. So I plugged in a 3, and I simplified it, and I got a 0. Okay? So I'm just going to keep doing that for each of these numbers. Okay, so let's get rid of the 3, and instead of 3, I'm going to put in a 4. Okay, that's the next number on my list. So now this says the square root of 4 minus 3. Well, that's 1. 1 times 2. Well, that gives me a 2. Okay? When I plug in a 5, okay, when I plug in 5, I actually get 5 minus 3, which is 2, right? The square root of 2 is not a nice number. All right, so I'm just going to bring up my calculator real quick, and I'm going to say, okay, 2, and let me hit my square root button. Well, that's about 1.4. 1.4, then I have to multiply it by this 2, right, to finish up the problem. 2.8, right? So I'm going to say when I plugged in 5 and I simplified it, I got about 2.8, okay? When I plug in 6, same thing. 6 goes in here, it's the square root of 3, so I'm going to say square root of 3, multiply that by 2, okay? And that comes out to be about 3.5, okay? I'm not going to use my calculator for 7, because when I plug in a 7 here, okay, let's get rid of this and put in a 7. 7 minus 4, I'm sorry, 7 minus 3 is 4, and I know that the square root of 4 is equal to 2, right? So this is just 2 times 2, 4, okay? So let's graph these points. So I'm going to say 3, 0, 4, 2, 5 goes up to 2.8, 6 goes up to about 3.5, and 7 is exactly 4. Okay, so here's what the picture of my graph is going to look like. Okay, it's going to be this line that kind of goes like that and shoots over. Okay, and it's kind of like a half of a U shape. Remember, our parabolas were a big U shape. It's a half of a U shape, but that's on its side. So, that's our graph. Okay, so again, the big idea here is only certain numbers can be plugged in. We have to figure out what that is before we graph.